Topic 5.4. We're going to be solving this problem right here. It's exponential. And the way that I'm going to solve this is I'm going to introduce a logarithm base 3 on both sides. So, log base 3 of 3 raised to the x minus 3 and log base 3 of 8, 4 minus x. Now, there are two reasons why I introduced the log base 3 to both sides. The first reason is that the logarithm has the property that we can take these exponents down and make them coefficients. So this will become an x minus 3 times log base 3 of 3. And this will become 4 minus x times log base 3 of 8. So, again, the first reason why I've introduced a log on both sides is that it gave me the ability to take the coefficients, the exponents down and make them coefficients. The second reason why I chose log base 3 in particular is because here I have log base 3 of 3. Log base 3 of 3 is a constant, and that constant is 1. Log base 3 of 8 is also a constant. I'm not sure what that is, so I'm going to just write that as c. It'll be a constant c, and we'll figure out what that is later on. So, 1 times x minus 3 is x minus 3. A c times 4 minus x is 4c minus xc. Now, solving for x, I will place all my x's on the same side. So I'm going to add xc to both sides, and then I'm also going to add 3 to both sides. That's going to give me x plus xc equals 4c plus 3. Now that we have the x's on the same side, I can factor out my x's here. This will give me x times 1 plus c equals 4c plus 3. And now I'll divide both sides by 1 plus c. This will give me x equals 4c plus 3 all over 1 plus c. Now, remember, c represents log base 3 of 8. That can be converted into log base 10 of 8 divided by log base 10 of 3. Now, these are log base 10s without the numbers here, without the bases. So, x equals 4 times log base 10 of 8 divided by log base 10 of 3, and then plus 3, all over 1 plus c again, which is log base 10 of 8 divided by log base 10 of 3. Okay, now when we put this into the calculator, I'm going to use parentheses for my numerator and denominator. Let's see here. I'm going to use a parenthesis for this numerator and then close it, and then for this denominator and close it. So, let's begin. Open parenthesis 4 log of 8 close parenthesis divided by log of 3 close parenthesis plus 3 close parenthesis divided by open parenthesis 1 plus log of 8 close parenthesis divided by log of 3 close parenthesis and then close parenthesis. And I get 3.65. 3.65. And this is approximation because we had to round. Number 8. All right. this has the look of a quadratic. In order to see that if it's in quadratic form, we're going to let u be equivalent to e to the x, to this portion right here. Well, if u is equivalent to e to the x, then u squared will be e to the x times e to the x, which is e to the 2x. Does this match this piece? And it does. So this is quadratic form. So I can rewrite this as a u squared minus 4u plus 3 equals 0, and solve this as a quadratic. So I'll try factoring. We'll get u times u, and for 3, let's try 3 times 1. The signs have to be the same, so let's make it negative in order to get a negative 4u in the middle. And I'm going to take u minus 3, set that equal to 0, and u minus 1, set that equal to 0. And this implies u is 3 and u is 1. Okay, now that solves it in the quadratic form. Now, let me substitute back for my e. So u equals e to the x, so this is e to the x equals 3, and this is e to the x equals 1. Now to solve this, I'm going to convert this into a logarithm. So this will be e and the 3 together. So log base e of 3 will equal x, and here log base e of 1 will equal x. Well, a log base e is essentially the natural log of 3. The natural log of 3 is ln 3, and that's going to be approximately 1.098. Okay. The log base of any number of 1 will always be 0. Okay. And both of these numbers, 1.098, can be placed in here for x because exponentials, their domains is all real numbers, and also 0, so they both work. So we have two solutions.